Hi, and welcome to the section Securing Apps with the Spring Security Framework, which is the last section of this course. In this section, you are going to learn about Spring Security, its architecture, and features in version 5. Also, we will discuss its different ways of implementation. In the first video, we are going to discuss Spring Security and its architectural design. In the second video, you are going to learn about HTTP security in enterprise applications. In the last video of this section, we will discuss Webflux security and its implementation. So let's get started. The title of this video is Spring Security and its architectural design. In this video, first you will have an introduction of Spring Security. Then we will discuss advantages of Spring Security. You will also look into its architectural details. Lastly, we will discuss Spring Authentication and access control. So let's move forward. At first, let's have an introduction of Spring Security. Spring Security is a powerful and highly customizable authentication and access control framework built on the top of Spring Framework. Spring Security is very flexible, supporting a wide range of authentication protocols, for example, FORM, BASIC, and OpenID, and several access control mechanisms with security policies defined at the level of URL in a web environment, at the level of Java method, or ACLs for fine-grained resource protection. Access rules can also be expressed in several ways, including simple role, group-based access, and spell scripts. Spring Security provides mostly a self-contained security solution, making applications and configuration fully portable across JEE application servers, servlet containers, other deployment environments. So, in a nutshell, it overcomes all the problems that come during creating non-Spring security applications and managing new server environment for the application. Now let's have a look into the advantages of using Spring Security. Spring Security has numerous advantages. For example, it provides comprehensive support for authentication and authorization. It supports protection against common tasks and also supports servlet API integration. It provides support for integration with Spring MVC. It is useful for its portability. It supports CSRF protection. It also comes with Java configuration support. Now let's look into the architecture of Spring Security. Application security boils down to two more or less independent problems: authentication, which means who are you, and second one is authorization, which means what are you allowed to do. Sometimes people say access control instead of authorization, which can get confusing, but it can be helpful to think of it that way because authorization is overloaded in other places. Spring Security has an architecture that is designed to separate authentication from authorization and has strategies and extension points for both. The authentication subsystem is responsible to establish the validity of client credentials, for example, username or password, or access token. Enforcing a security policy always involves an act of preemption performed by an interceptor to check if access is allowed. For URL level access control, interceptors are used, and for method level access control, a Spring AOP proxy and a round advice is used. In a web environment, Spring Security uses a pipeline of collaborating filters. Collaborating filters, each responsible for part of the overall Spring Security solution. To simplify configuration steps, a master of the class FilterChainProxy is responsible to assemble the pipeline. One of the created filter security interceptor is responsible to preempt threads and interact with the access decision manager. Username password authentication filter used in the form-based authentication is responsible to authenticate the principal by extracting the credential from a request and by interacting with the authentication manager. So that's how Spring Security Chain works. Now let's explore Spring Authentication. An authentication manager component is responsible to coordinate one or more authentication provider, each implementing one authentication approach. Let's look into the code for Authentication Manager interface. This is the Spring provided Authentication Manager interface, which has only one method, authenticate. An Authentication Manager can do one of the three things in its authenticate method. First one, it can return an authentication normally with authenticated is equals to true if it can verify that the input represents a valid principal. Secondly, it throws an authentication exception if it believes that the input represents an invalid principal. Lastly, it returns null if it can't decide. A provider manager can support multiple different authentication mechanisms in the same application by delegating to a chain of authentication providers. If a provider manager doesn't recognize a particular authentication instance type, it will be skipped. Authentication can be done in different forms. For example, it can be credential-based, two-factor, or hardware authentication. Also, it has different mechanisms for all different forms. For example, basic authentication mechanism, form authentication, or Java authentication and authorization service, which is known as JAS. Also, Spring authentication uses different storage types as well. For example, RDBMS, LDAP, or any custom storage. Let's look into the code for basic authentication mechanism. This is our pom.xml file in which we have mentioned a dependency of Spring Boot Starter Security. Here we are registering basic authentication filter and basic authentication entry point as a bean in the Spring context. Basic authentication is by default enabled when you add Spring Security in your class path. You need to configure the username and password for basic authentication. Lastly, we have configured Spring Security in this application using XML2, in which we are providing authentication provider and a user service by providing a user with the name and password and its role. So this is how to enable basic authentication in Spring Boot applications using Spring Security. Once authentication is successful, we can move on to the authorization, which is also known as access control. And the core strategy here is access decision manager. There are three implementations provided by the framework, and all three delegate to a chain of access decision voter, a bit like the provider manager, which delegates to the authentication providers. Authentications can be handled before URL invocation and after URL invocation as well. Also, we can implement authorization on the basis of votes and expressions. An access decision voter considers an authentication a secure object which has been decorated with config attributes. It is very common to use config attributes that are spell expressions. For example, is fully authenticated and has role foo. This is supported by an access decision voter that can handle the expressions and create a context for them. Let's look into the code for Spring Access Control. Here we have two configure methods. In this configure method, we have added one user with user's role. Like this, we can configure any number of users and roles. We can either use roles method or we can use authorities methods to configure roles in our application. Difference between authorities and roles methods is that authorities needs the complete role name like role_user, while on the other hand, role name like user, it will automatically add the role_value to this user's role name. In this second configure method, we are passing HTTP security object in the argument, and we have defined a URL with required access rules /login static URL, which is accessible by the roles users. And we are authorizing this using authorized requests. So that's how you can provide authorized access to web application pages.